In this video I'll explain two methods to resolve a vector, one by using a drawing to scale and the other using trigonometry. In this old picture you can see a lady pushing her child in a sled on the ice. She pushes in the direction of the handle. Thereby the force she exerts on the carriage acts downwards as well as forwards. To determine the effect of the force, you need to know to what extent the force works in the horizontal direction as well as in the vertical direction. This is done by resolving the given force in separate components or directions. Now there are two ways to resolve a vector, either by drawing the force to scale and measuring its components, or by using trigonometry and calculating the components. I will demonstrate both methods. Let's first draw the given force to scale. It is given that the force is 100 newtons. Now choose a convenient scale, for instance 1 centimeter to 20 newtons. Thus the vector of the force is 5 centimeters long. You can clearly see that the lady pushes downwards and a bit forwards. Now from the starting point of the force, draw a dashed vertical line and a dashed horizontal line. These are the directions of the force components in the vertical and horizontal directions. Next, place your triangle parallel to the vertical line and move it to the arrowhead of the force. There, draw a dashed vertical line up to the point where it intersects the horizontal dashed line. Now you know the length of the horizontal component and I will draw a proper force vector. The same applies for the vertical component. Place your triangle parallel to the horizontal component and move your triangle parallel to the arrowhead of the original force. Here you need some support lines. Again, draw a dashed line up to the point where it intersects the vertical line so that you can draw a proper force vector. Now you know the two components of the given force. These components are often denoted by F parallel and F perpendicular. Or in this case perhaps you could also say F x and Fy. The angle here is 30 degrees. Now you could now measure the lengths of these components and use a scale 1 to 20 newtons to calculate the corresponding forces. Next I'll show a second method in which you can calculate the two components. Note that you can recognize a triangle in this drawing with a right or 90-degree angle. You can use trigonometry and Pythagoras to calculate the separate components. First of all, you need to know the angle, which is 30 degrees, and the hypotenuse, 100 newtons. Now suppose you need to know the vertical component, which is the adjacent of the given angle. Use the memory aid SOHCAHTOA. So the sine of the angle equals the opposite divided by the hypotenuse. The cosine of the angle equals the adjacent divided by the hypotenuse, and the tangent of the angle equals the opposite divided by the adjacent. We know the hypotenuse, so we can't use the tangent. And we know the adjacent, so we can't use the sine. So the cosine of 30 degrees equals the adjacent, which is the vertical force component, divided by the hypotenuse, which is given as 100 newtons. Rearrange to find that the vertical component equals 100 newtons times the cosine of 30 degrees. Use your calculator to find the answer, which is 87 newtons. You can do the same for the horizontal component. The horizontal component now is the opposite side, so you need the sine. Therefore, the sine of 30 degrees equals the parallel component divided by 100 newtons. Rearrange to find that the horizontal component equals 100 newtons times sine 30 degrees. And use your calculator to find that it is 550 newtons. Now you can check your answer using Pythagoras. The hypotenuse squared should equal the sum of the two components squared, which are the right angled sides. So 100 squared should equal 87 squared plus 50 squared. Let's check using our calculator. 87 squared plus 50 squared equals 10,069. And 100 squared of course equals 10,000. Not exactly the same because we have rounded off our answers. You now know two methods to resolve a vector, by drawing the vectors to scale and by using trigonometry.